All right, this is lesson 3.2, part B, starting on page 137 of the workbook. And we're going to do the distributive property, and this is hopefully review for you. So we have, when we're multiplying this, it's this times everything in here. We have two x plus 1s. So that means that I have 2 times x, and I have 2 plus 1, so that equals 2x plus 2. And 3 times x plus 3 is x squared plus 3x. And 2x times x minus 2 in brackets it's 2x times x, which is 2x squared. Now, sometimes it's helpful to think of this as 2x times x plus negative 2. Because then what I have is 2x times x, so 2x times x, and I have 2x times negative 2. So I get 2x squared minus 4x. Okay, so that's kind of the long way of doing it. And if that's how you need to do it to get the right answer, well then, for goodness sake, do it that way. Eventually, though, you'll hopefully be able to shortcut that a bit, that it's 2x times negative 2, which is just the negative 4x. Okay, but however you get there is great. Okay, I have negative 3 times x, so that's negative 3x, and then negative 3 times negative 1 is positive 3 or plus 3. And here I can do this the same thing. The big rule actually is everything inside the first brackets times everything in the second factor or brackets or whatever you want to call it. So I've got to go x times 2x, which is 2x squared, and then negative 1 times 2x, which is minus 2x. All right. Okay, so these are examples of the distributive property, and you can extend it to any number of terms. That's what I was saying. It's everything in the first term, or the first factor times everything in the second factor. And we will get into that later on this year. Okay. This is just me showing you that this is true using numbers instead of letters. Okay. So if I have this expression, negative 2 times 3 minus 5, and I calculate what's inside the brackets first, because that's my order of operations. That's how I learned this first. I have negative 2 times negative 2, which equals 4. And if I use the distributive property, it's negative 2 times 3 and negative 2 times negative 5. So negative 2 times 3 is minus 6. And negative 2 times negative 5 is positive 10. And that also equals 4. So I get the same result either way. Okay. Now, I've seen it happen where once we've learned this distributive or the distributive way of doing it, kids always want to do it this way. Don't. If you just have numbers, going back to your order of operations, that's way simpler. Okay. So if you've only got numbers, go ahead and follow your order of operations. Save the distribution for when you have variables in there and you can't just use order of operations. All right. But then again, I don't care how you do it as long as you get the right answer, but that's my suggestion. Okay, maybe you want to pause and try these questions before you watch me do them. This is going to be 4 times 3x, which is 12x, and then 4 times 1, so that's plus 4. Negative 5 times 2x squared is minus 10x squared. Minus 5 times x is minus 5x, and minus 5 times negative 6 is plus 30. Here we've got x cubed times x squared. That's going to be x to the 5. And then minus 2 times x squared, so that's minus 2x squared. Negative 3x times 7x, that's minus 21x squared, plus negative 3x times negative 2y, that's going to be 6xy, and then negative 3x times z is negative 3xz. Okay? And again, if you need to write it out, why don't I just write this one out the longest way that you can do this. So this is going to be negative 3x times 7x, and it's negative 3x times 2y, or negative 2y, actually, because and means plus, right? So it's and this thing times this thing, and negative 3x times z. Okay, so that's how I get this. All right. So this is what we call expanding a polynomial expression. We talk about when you're working with just numbers, we say multiply, and when you're working with polynomials, we say expand, because you don't get an actual number when you do this. Okay, so that we just call that expanding. Okay. Next page. Okay, so now I've got two parts of this. I need to follow my order of operations properly here. So this 6 is just going to hang out for a minute because I have to do my multiplication first. Okay, so I've got negative 4 times 8x, that's minus 32x, and negative 4 times 1 is negative 4. So then I can collect my like terms. I've got 6 minus 4 and minus 32x. 6 minus 4 is 2 minus 32x. That's my answer. Now, if I wanted to check this, I could plug a value in for x and see if I get the same answer. And I totally encourage you to do that. All right, here we've got to do this multiplication and this multiplication before we do this subtraction. Okay, so 4 times 2x is 8x, and 4 times minus 3 is minus 12. And then I've got, there's a plus here because there's an and, but we don't usually put that in there. Now I've got negative 2 times x is minus 2x, and minus 2 times negative 6 is plus 12. So you can see that this plus here doesn't actually do anything. Okay, so that's why we don't usually bother writing it in there. So now I've got 8x minus 2x is 6x, and minus 12 plus 12 is 0, so the answer is just 6x. All right. This one is even more, there's more going on here. I'm going to draw my rainbow lines underneath here because they are helpful and I just don't have room up on top. So I've got 5x times 3x squared. That's 15x cubed. This is minus 35x squared plus 5x. And then I've got minus. Remember, there's a minus 1 here. We have to change. Remember, when you're subtracting a polynomial, you're changing the sign of everything in there. But you can also think of it as a distribution. So if I've got minus 1 times 4x, that's minus 4x. And I've got minus 1 times 3x squared, so that's minus 3x squared. And now I can collect my like terms. I've only got the 15 with the x cubed, so that's 15x cubed. And then I've got minus 35x squared minus 3x squared, and then plus 5x, and minus 4x. So I underlined each term as I rewrote it so that I knew that I had actually moved them all or rearranged them all. I also am taking the sign that comes before it as part of that term. Okay. Now it's easy for me to actually add together like terms. So I've got 15x cubed minus 38x squared minus x. Okay, there we go. That is the answer. Last examples here. This is anytime you see something like this and your brain goes eek, because it looks scary. Make it a simpler problem. Okay, so if I do, let me redraw this. And what if instead of it being these polynomial answers or questions or expressions, I say, well, this is 2 and this side is 4, and this is, well, if I look at my diagram, this looks like 5 and this looks kind of like 4 as well. Okay, So if I have that, how do I find, oh, maybe I need to back up a little bit. This is to add the areas of two rectangles. So that means that I'm either going to divide it like that, and this is one area and this is the other area, or I'm going to cut it like this, okay? I would probably have done it the first way, but somebody else showed me this, and this is much easier if I do it this way, because if this is 2x, I know that this is 2x. This one here is 2x. Okay, that's what I was going to show you over here, is how do I figure out what this distance is? Well, if I know that this is 4, this is 2, so I subtracted them, right? I took what I have over here and I subtracted 2. So the same thing here, if I've got 4x here and I take away 2x, I'm left with 2x here. And then for this one, that's all I need to do because I already know what this one is. So I'm going to call this area A, and this is area B. So my equation is going to be, or my equation, I guess, my area total is going to be the area of A plus the area B. And it's worth writing that down because then, like I was talking to somebody today about, when you go down the rabbit hole, you can find your way back out. That's why we do this, okay? So area of A, area is length times width. So it's going to be 2x times 3x plus 2. So that's my area of A. And area B is going to be 2x times x plus 5, right? So then I'm just going to do my distribution, 2x times 3x, draw my lines that way. So 2x times 3x is 6x squared, plus 2x times 2 is 4x, plus 2x times x is 2x squared, plus 2x times 5 is 10x. And then I've got to collect my like terms, add that all up. I've got 6x squared plus 14x. Oops. Okay? And then it wants me to come over here and subtract the area of two rectangles. So that means that I'm going to make this whole big rectangle, and I'm going to subtract this little piece. So what is the area or the side lengths of this little piece? Well, I already know that this one is 2x. What is this one? Well, if you're not sure, you come over here. I know this is 2. How long is this side? And I'll bet most of you can look at that and just say, well, it's 1. How did you do that? Well, if this side is 5 and this is 4, you go 5 minus 4 leaves what's left because, you can do this and it's a rectangle. So this side has to be 1 because 1 plus 4 has to equal 5. So over here, I have to do 3x plus 2 minus x plus 5. And this is because of the way the space is, this is a good place to practice my vertical subtraction. So if you're ever doing the vertical subtraction, please, 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 please put a big minus sign over here. And this has to be in brackets because if you write it as 3x plus 2 minus x plus 5, it looks like I'm subtracting the x, but I'm adding the 5, and that's not what I'm going to do. So that's wrong. I'm going to go 3x minus x is 2x, and 2 minus 5 is minus 3. Okay? And I can check that if I want, because 2x, minus 3 plus x plus 5, 2x plus x is 3x, and minus 3 plus 5 is plus 2, which is what I needed it to be because it had to equal the total length of the big side. Okay, so this time I'm going to say that my area total is my area big minus my area small, because it's hard to label the big rectangle on this diagram since it's like cut into pieces. So it doesn't really matter how you do it. You could say that it equals the area of the big rectangle minus the area of the small one that kind of looks more like a square. As long as you're doing something that is meaningful to you and I can probably figure out what you're doing, that's great. Okay, so the area of the big one is going to be 4x times 3x plus 2. And then I'm going to subtract the area of the smaller one. Oh, I can write this in here. This is 2x minus 3. That one there is 2x minus 3. So it's going to be 2x times 2x minus 3. Now you might be noticing that I am putting the monomial first and the binomial second, and it's just that's the way we usually do it, and it seems to be easier that way. But I want you to know you can do it the other way, and that's fine. If you do it correctly, you're still going to get the same answer. Okay. So we've got 4x times 3x, that's 12x squared, plus 4x times 2, that's 8x. And then it's minus 2x times 2x, so that's minus 4x squared. And then negative 2x times negative 3 is plus 6x. And then I'm going to collect these things. I've got 12x squared minus 4x squared. Wait, that's 8x squared. Did I make a mistake on the other side? Yes, I did. This should be 8. I don't know where the 6 came from. Okay, that should have been x. 6 plus 2 is 8. So yeah, oops, sorry. And then 8x plus 6x, that's 14x. Okay, so I did get I got the same answer both ways. Which one's easier? You know, it depends on the situation, depends on what's given to you, how hard it is to find what you're missing, whatever you want. It's just different all the time. I do want to point out though that I did make a mistake and I didn't die, but I did go back and figure out why I had a mistake. What was the actual mistake that I made? And that's really important because that's where you learn, okay? For me, it was just a careless mistake. For you, it might be something that you didn't know. So it's important to figure that out, okay? All right, and that is the end of this lesson. Have fun with the practice. Bye.